So in this video, we're going to go through some practice problems related to interest rate, nominal and effective, and converting from one time period to another. So the first practice problem we're going to look at is you went on a trip to Europe. You went on a trip to Europe and spent $4,000. All of this went into your credit card that charges 18% compounded monthly. You will pay this off in 2 years. What will the monthly payments be? So let's look at the information we know. We know that the nominal interest rate, or R value, is 18%. M, or the compounding periods per year, is 12 months, or 12. The number of years that we're thinking of doing this is 2 years, and the initial value is P. So since we want to pay off this loan monthly, every month, then that means that one period is going to be equal to 1 month, and that's the period definition. So given that, we're going to put this information into the values that we need, where the interest rate per month is R over M, or 18% divided by 12, 1.5% a month. The number of periods now is 24 months, because that's how a period's defined, and the p-value is still 4,000. So if we just go ahead and put this into the factors, we can look it up in the 1.5% table, and it seems that we will have to pay about $199 or $200 a month for this $4,000 loan. So from the previous problem, you found that you'd pay almost $200 per month for 2 years. And you're wondering, if you had put this amount in the savings for the 2 years prior to your trip, how much more money would you have? And just think your savings account will pay 10% compounded daily, which is not really how much they pay. That's a large amount, but let's just pretend. So let's look at that. So now we have a 10%. We have a different compounding method, but because of the word compounded, we know that it's a nominal rate. The number of compounding periods is 365. The number of times the payments are going to be occurring is 12 times per year for 2 years, and it's a $200 payment. So by definition, we're going to define the cash flow frequency as 1 month. So that's how often we want to make the payments. So that means we need to figure out what's the interest rate per month, and we're going to use the equation 1 plus R over M to the M over K to get to almost 0.5% a month, or 0.48% per month for 24 months, not 2 years, because we're converting everything to months, and the payments are about $200. So we're going to use this equation because 0.48 does not occur as a table. So we're going to use that equation, and that means what we're going to have at the end is $5,066 instead of $4,000. So if you had saved up, made the same payments for 2 years prior to your going away to Europe, you would have had $1,000 more dollars. That's quite a bit, 25% more. It's a lot. So the next problem we're going to look at, if I can click. So in this problem, you're looking at two different payment methods. One is $400 per month for 3 years, and the other is $4,800 per year. So it's the same dollar amount, it's just the timing is going to be different. And you're looking at an interest rate of 12% compounded monthly, and you want to know which is going to be the best deal for you. So let's just first look at the monthly deal. So in this case, we know R is 12% and M is 12 months for 3 years, and it's $400. So we know that the cash flow is defined as 1 month, because that's how often the cash flow frequency is calculated. So then we're going to get the interest rate per month is going to be R over M, 12% over 12, or 1% a month for 36 months, and the $400. So that gives us $17,230 if we look this up in a table. Okay, now let's look at the yearly one. So in the yearly rate, we have M is 12 months, R is 12, M is 12 months. It's 3 years for 48 months. And the cash flow is defined as 1 year now, because that's how often the cash flows, the period is defined as 1 year, because that's how often the cash flows occur. So now we need to know the effective rate per year. So we're going to go 1 plus R over M to the M. That was the equation we covered a couple videos ago. That gives us 12.68% for 3 years, and it's $4,800 per year. So there's no table that has 12.68 in it, so we're going to plug it into this value, and we're going to get 16,303. And then the monthly deal, we had 17,230. So monthly is better because we have more time to earn interest on the monthly payments. So I hope that helped you in these couple of practice problems.